From the silver-capped waves of the Pacific, schools of tuna surge forward like living jet engines. Restless travelers, swimming tens of thousands of nautical miles without pause. Yet their story does not end at sea. Each year, more than 7 million tons of tuna are harvested, swept from the open ocean into a vast industrial chain. From fishing decks blazing with floodlights at night to icy steel conveyors inside modern processing plants. Welcome to AgroWorks USA, where we uncover the untold journeys of food on a truly global scale. In this video, we'll dive into the world of tuna, one of the ocean's fastest predators and one of humanity's most valuable harvests. You'll see the fleets and nets that capture them, the precision of frozen cutting technology, and the intricate canning lines that transform raw power into a staple food reaching households in every corner of the world. Don't forget to like, subscribe, and ring the bell, because behind every can of tuna lies a story of speed, technology, and the ocean's immense gift to us all. Tuna are not just fish, they are the jet fighters of the ocean. Streamlined bodies and powerful muscles propel them at speeds of up to 75 kilometers per hour, slicing through waves faster than a car in city traffic. Some species, like yellowfin and bigeye, cross entire oceans in their lifetime, covering tens of thousands of nautical miles without rest. Their hearts pump twice as fast as most fish, keeping their muscles warm even in frigid waters, an evolutionary engine built for endurance. Every year, the world hauls in more than 7 million tons of tuna, enough to feed an entire continent. Major fishing grounds span the Pacific, Atlantic, and Indian Oceans, with the Central and Western Pacific alone providing over half of the global catch. These schools migrate with warm currents, following trails of sardines, squid, and mackerel that stretch for thousands of miles. From May to September, the peak season, oceans transform into vast arenas where sonar, spotter planes, and Persicen nets race to intercept the sea's fastest travelers, turning wild energy into a global food supply. Tuna fishing at industrial scale is nothing short of an ocean-wide operation. The most common method is the purse-seine net, a floating wall of mesh that encircles entire schools in one swift maneuver. Once the net is deployed, the bottom is drawn tight like a giant drawstring, locking in thousands of fish. A single set can haul in 100-200 tons of tuna, enough to supply factories for days. To find their quarry, fleets deploy an arsenal of technology: satellite tracking, sonar, drones, and even helicopters. Spotters look for seabirds diving or the shimmer of silver schools near the surface, signals that guide vessels into position. Once spotted, engines roar and nets unfurl, stretching across the waves for miles. Within minutes, the catch is funneled aboard using hydraulic cranes and steel conveyors, the decks awash with flashes of blue and silver. For high-value species like yellowfin or bigeye, longline fishing takes precedence. Miles of baited hooks trail silently through the currents, yielding fewer fish but of premium quality destined for sushi counters in Tokyo or New York. This is tuna at industrial speed, a marriage of manpower and machine that turns the open sea into a conveyor belt for one of the world's most valuable fish. Do you think advanced harvesting technology could change the fate of tuna in the future? Do you believe traditional fishermen still have a place in this modern industry? Share your thoughts in the comments, and don't forget to like, subscribe, and ring the bell to stay with AgroWorks USA. Once hauled from the ocean, tuna face their most critical race, the race against time. Freshness determines both flavor and value, and the only way to preserve it is through a rigorously managed cold chain at sea. Onboard industrial vessels, the process begins within minutes. Deck crews slide each fish into slurry tanks, a swirling mix of seawater and crushed ice that rapidly chills the core temperature close to freezing. For premium species such as bluefin, some vessels take it further, using blast freezers that plunge tuna to 60-degree Celsius, a temperature so cold it locks in texture, color, and fat content for months without loss. The logistics behind this system are staggering. Massive refrigerated seawater, RSW, holds circulate chilled brine through compartments large enough to store hundreds of tons, with sensors tracking every degree. A single pump failure, a delay in freezing, or a break in circulation can mean millions of dollars lost, as flesh deteriorates quickly once the chain is broken. When holds are full, carrier ships rendezvous mid-ocean, loading frozen tuna into reefer vessels, giant floating warehouses that maintain sub-zero conditions across voyages lasting thousands of nautical miles. By the time tuna reaches port, it is almost as pristine as the moment it left the water. The journey of tuna does not end at the dock. It transforms inside the walls of vast, high-tech processing plants where precision defines every step. Frozen giants, some weighing more than 300 pounds, are lifted by cranes and placed on roaring conveyor belts. At sub-zero temperatures as low as 40 degrees Celsius, diamond-coated industrial saws slice through rock-hard flesh. Cutting tuna while frozen preserves its structure, locking in the deep red color and firm texture that sushi masters and consumers demand. From here, the fish splits into two paths. Large fillets of yellowfin and big eye are carefully portioned for fresh export markets and premium sushi counters, where each slice can sell for hundreds or even thousands of dollars. Skipjack and smaller tuna, on the other hand, enter the canning lines. Here, speed meets craftsmanship. Massive steam cookers soften the flesh before skilled workers trim bones and skin by hand. Machines portion the meat into tins, add brine, oil, or sauce, and then seal them with mechanical seamers. Finally, the cans are sterilized under pressurized steam at 121 degrees, ensuring food safety and long shelf life. Quality checks never stop. Automated cameras, weight sensors, and human inspectors scrutinize each can. By the end, thousands of gleaming tins roll off the line every hour, each a story of tuna's journey from ocean predator to global pantry staple. Are you surprised that frozen tuna can be sliced with diamond-coated saws? Do you think the delicate manual work of factory workers could ever be replaced entirely by machines? Let us know in the comments. I'd love to hear your perspective. Once processed, tuna becomes one of the most traded seafood products on Earth. Each year, more than 7 million tons enter global markets, feeding households from Tokyo to New York. Thailand leads as the world's canning hub, handling nearly 30% of global exports, shipping millions of tins across Asia, Europe, and the United States. In contrast, Japan and Spain dominate the fresh and frozen tuna trade, importing high-value cuts of yellowfin and bluefin for the lucrative sushi and sashimi markets. A single premium bluefin fillet can fetch thousands of dollars, making it a centerpiece at elite restaurants. In the US, tuna is a pantry staple. Over half of households purchase canned tuna annually. In Europe, Italy and Spain consume vast amounts, folding tuna into pasta dishes, salads, and snacks. Even in Africa and the Middle East, imports are rising as tuna offers affordable protein for growing populations. But tuna is not just food, it is an economic engine. From artisanal fisheries in the Philippines to mega factories in Bangkok, millions of jobs depend on it. Each can, each fillet, represents a chain of value that links fishermen, processors, retailers, and consumers in one global network. Behind every tin of tuna lies a fragile balance. Each year, global fleets haul in more than 7 million tons, and scientists warn that species like bluefin face collapse if overfishing continues. Industrial Percy-Sen nets and long lines, while efficient, often sweep up sharks, turtles, and other unintended species, bycatch that threatens entire marine ecosystems. The environmental toll extends beyond the water. Fishing fleets burn massive amounts of fuel, and factories must maintain sub-zero cold chains, consuming enormous energy. The paradox is clear. Tuna feeds billions, but risks depleting the very oceans that sustain it. Yet change is underway. Certifications like the Marine Stewardship Council now push fleets toward traceable, sustainable catches. Governments enforce quotas, seasonal bans, and satellite monitoring to protect stocks. Some regions are even pioneering tuna aquaculture, an attempt to shift pressure away from wild populations. Still, the question remains, can we meet global demand without exhausting the seas? The answer will shape not only the future of tuna, but the resilience of our oceans themselves. From the Pacific waves to supermarket shelves, tuna tells a story of scale and connection. Each year, more than 7 million tons are hauled from the sea, linking fishermen, factories, and consumers across continents. Every can or fillet is not just food, it is the result of speed, technology, and human effort. Yet abundance carries risk. Overfishing, climate change, and fragile ecosystems remind us that today's plenty could become tomorrow's loss. Tuna is both a lifeline for millions and a measure of how wisely we manage the oceans. Its future depends on balance between profit and preservation, demand and sustainability. Which path do you believe tuna will take? Share below and remember to like, subscribe, and ring the bell for AgroWorks USA.